Hi children, how are you? Today we will discuss the heat and temperature level 1 problems. First one, a thermometer works on the principle of option A, linear expansion of solid, B, cubical expansion of solid, C, uniform expansion of volume of liquid or gas with temperature, D, both B and C. Think, what is the answer? Yes, the thermometer works on the principle of uniform expansion of volume of liquid or gas with temperature, and it is called as cubical expansion of liquid. So the answer is option D. Next one. Which thermometer ranges from 10 degrees centigrade to 110 degree centigrade? A. Digital thermometer. B. Clinical thermometer. C. Laboratory thermometer. D. All of this. If you observe these figures, right? This is the digital thermometer. Can you have any scale here? No. And this is a clinical thermometer. In the clinical thermometer, the range is not from 0 to 110 degrees. So it is also not the answer. Digital thermometer is also not the answer. So the remaining one is laboratory thermometer. What is the answer? Laboratory thermometer, where yes, the range may be, see, minus 10 and to it is up to 120. So the range from 10 degrees centigrade to 110 degrees centigrade, that will be measured in the laboratory thermometer. Next, which scale has lower fixed point at 0 degrees? So which is having 0 degrees? Look at the three figures: Kelvin scale, Celsius scale, Fahrenheit scale, right? So what is the lower fixed point? Yeah, water freezers, right? The water freezers, we call it as lower fixed point. The lower fixed point of Kelvin is 273 Kelvin, Celsius 0 degrees Celsius, and Fahrenheit 32 degrees Fahrenheit. So what is the answer? Yes, the 0 degree Celsius is a lower fixed end point in Celsius scale. Which scale has lower fixed point at 0 degrees? Yes, Celsius scale. Why is a digital thermometer widely used? Why? Because it is cheap, because it is accurate and precise, easy to use, D, fast. Though it is cheap, no, it is not cheap. Fast, yes, it is fast, but if the thermometer showing the wrong readings, what is the necessary of fast? Yes, it's not that. Easy to use, yes, easy to use, but the most important function of the digital thermometer is accurate and precise. Why it is accurate and precise? Because in clinical thermometer, the person may commit mistake, that is error, while observing, right? But in digital thermometer, it is having a display, so there is no chance of error, so it is accurate and precise. When one end of an iron rod is heated, its other end gets heated up due to, so what is the reason? Yes, see this figure, one end of the rod is getting heated, another one is slowly the heat will transfer after some time. Yes, if I hold this rod, I may get heat, right? And even I cannot hold the rod. So what is the reason? Yes, the heat is transferring from one end to other end, one end to other end. So this process is called the heat transfer from one end to other end, and with a direct contact, right? See here, the heat is directly contacting with the rod. So which type of heat it is? Yes, conduction, because the process of heat of transfer by the direct contact by direct contact, then it is called as conduction. Convection, yes, it is not having any direct radiation, no need of contact, and insulation, which does not pass the heat through it. So, what is the answer? Conduction. What happens when water is heated in a top? See, this is the top, this is the pot, and pot is having water, and I am applying the heat. What happens? The bottom of the water molecules first will they get heat up, and slowly they will move up. Whatever the molecules which are cold water molecules, they'll move down. So this circulation will help to distribute the heat uniformly throughout the water. So if entire water reaches the standard temperature, that is 100 degrees centigrade, yes, the water starts getting, yeah, what is that? Water vapor. So it will convert into water vapor, that is a gaseous state of water. Now, so let's check the options. Heat is a form of energy. What happens when water is heated in a pot? Heat is a form of energy. Option B, water can boil itself. No, water cannot boil itself. I need to apply the heat. Water develop heat on its own. No, the heat should supply. None of the above. No. Yes. What's the answer? Heat is a form of energy. Next question. In which option is chemical energy converted to heat energy? Yes, what is the first option? A, heater. In heater, what is happening? Yes, electrical energy is converting to heat energy. Yes, I am supplying the electrical energy. That electrical energy is converting to heat energy. So the option A is wrong. Refrigerator, yes, what happening in refrigerator? Yes, I'm supplying the electrical energy. That electrical energy is it is decreasing the heat, that is condensing the condensation process, heat decreases the heat. So this is also not the condition. Candle, yes. Candle, yes. If I lighten the candle, yes, the wax will melt. So even some of the wax will get evaporated. That is chemical energy is converted to heat energy. Yes. Let's check the other option also. What is that? Motor. Motor, what you are supplying to the motor? Yes, electrical energy. And the electrical energy is converted to mechanical energy. What is a mechanical energy? Any body moving, yes, it possesses the mechanical energy. Energy possessed due to its position and motion. So what is the option? Yes, candle converts mechanical energy into heat energy. What happens when a liquid changes into gas at a constant temperature? Yes, what happens when liquid changes to gas? Yes, if the liquid changes to gas, what is that? It is going to water vapor. The water is converting to gaseous state. That gaseous state of water is called water vapor. Now, water vapor, liquid changes into gas. Yes, the liquid changes into gas. That is called water vapor. At constant, at which temperature it happens? Yes, at 100 degrees Celsius. 100 degrees Celsius, the water starts. What happened at 100 degrees Celsius? The water starts boiling. If the water starts boiling, yes, then only water can be converted from liquid state to gaseous state. So what is the option? Boiling point. Now here if you see that evaporation point, why can't it be evaporation point? Why it is only boiling point? Yes. See, this in evaporation, yes, the liquid state will be converted to gaseous state, but not anything. It happens at any temperature. at any temperature, if the liquids convert into gases, that is called evaporation. That means no requirement of any supply of heat energy. That is, you are not applying any heat energy externally, right? Whatever the solar radiation, that is enough, and it doesn't require any particular specific temperature. Conversion of liquid state to gaseous state at any temperature below boiling point. What we call below boiling point, that is called evaporation, right? But in this figure, I am applying the heat energy, that is at constant temperature. Here the question asked about the constant temperature, and evaporation is at any temperature. So what is the answer? Boiling point, but not the evaporation point. Next, why are petrol storage tanks not painted black? Can you see this? What is the color of these tanks? Yes, these are called fuel tanks. These are fuel tanks. So what is the color of these tanks? White. Why they are not painted in black? They don't have black paint? No. Why they are not? Wantedly they are not painting with black. Reason is black is a good absorber. Black is a good absorber. Whatever the radiation, yes, it absorbs. Good absorber. So that's why we should not wear black colored dress on a sunny day or in summer season. Now, good absorber. So can you check it? It's a good conductor of it. Yes, it's a good conductor of it. Bad conductor? No, this option is wrong. Good reflector? No, it is a good absorber. Yes, it's a good absorber. Now, here, good conductor of heat, good absorber of radiation. Here, when we speak in the point of view of petrol storage tanks, obviously we will not supply heat to the storage tanks. That's why this option will not be valid. Now check this option. Black is a good absorber of radiation. Yes, whatever the sun radiation, if it absorbs, yes, the heat will be increased and the petrol will get evaporated and there is a chance of explosion. That's why, so we'll not paint black color for petrol storage tanks. So what is the option? Black is a good absorber of radiation. That's why we are not using for paint of fuel tanks. Not only petrol, even for every fuel tanks we will not use them as a, because they are good absorbers of radiation. Next, how heat is transferred in solid substance. See, so on the stove, I put the vessel, I put out the vessel. Now can you see that? Yes, the vessel got heat up. Now what is this process of transfer of heat? Yes, conduction. He, how? So what's the answer? Conduction. How it is transferred in solid substance? In solid, heat is transferred through conduction. Next, in conduction, heat flows from, yes, heat flows from colder to hotter region, hotter to colder region, colder to colder region, hotter to hotter region. So obviously heat will not from cold to cold, hot to hot, because if the temperature is same, the flow of heat will be stopped. So obviously there will be no heat flow, right? So there will be no heat flow. That is, there should be a temperature difference. So in colder to hotter and hotter to colder, yes, there is a temperature difference. So what is the option then? So there is a temperature difference. If there is a temperature difference, heat flows. Now look at this figure. This is the thermometer reading. In which end you will have high temperature? Yes, this, at this end you are having high temperature and it is having cold temperature. And how the heat is flowing? From hotter body to colder. So what is the answer? Hotter to colder region. Why? Because only the heat flows from hotter to colder region. Yes, whatever these molecules will have high kinetic energy. High kinetic energy. So when compared to the this side, colder side, so obviously if there is high kinetic energy, they are very active. So because of very active, they will move fast when compared to the colder region. So always heat flows from hotter region to colder region. Next, why does a glass tumbler crack when hot tea is poured into it? See, have you observed? See, if the hot tea is poured into a glass tumbler, that may crack. What is the reason? Glass contain glass cannot resist heat. No, glass expands unevenly around the place of contact with the tea. Tea has chemicals that react with the glass. None of them. So obviously tea doesn't have any chemicals. So it is not the option. Tea has chemicals that react with the glass. It's not an option. Now check to the other one. Glass cannot resist heat. No, it's wrong. Why? Glass is a insulator or a poor conductor of heat. Poor conductor of heat. So option A is also wrong. Now check the B. Glass expands unevenly around the place of contact with the TC. Though this is the glass tumbler, and the wall thickness of the glass tumbler will be more. If I pour hot tea into the glass tumbler, yes, this heat will try to expand. It try to expand the glass. But glass is a poor conductor of heat. The immediately heat is not transferred to the outer wall. So inner wall try to expand and the outer wall will not expand. Outer wall will not expand. Due to the inner wall expansion, outer wall is resisting the expansion, so the glass will break. This is called uneven expand. Glass expands unevenly around the place of contact with the tea. That's why glass tumbler crack when hot tea is poured into it. What is true about warm air and cold air? Right? What is the true about warm air and cold? Check the options. Warm air is heavier than cold air. Warm air is lighter than cold air. Both are equal weight, cannot be determined. No, both will not have equal weight. So option C eliminated. D cannot be determined. No, that is also not option. Now check the both. Warm air is heavier than colder air. Warm air is lighter than colder air. Already we saw that in the water, the water molecules will move up, the water molecules will move down. That means the higher, that is, whatever the heated molecules will have lighter, and these are weight. That's why what is the answer? Warm air is lighter than the cold air, right? So cold air is more dense than the warm air. That's why all our ACs, why they are fitted at the top level, because to whatever the warm air will escape up and the cold air will move down. So warm air is lighter than cold air. What is a measure of degree of hotness or coldness of your body? What is heat? No, heat is a form of energy. So we will not measure it. So yes, we will measure the heat of energy, but in terms of energy, not in terms of coldness and hotness. Energy, ability to do work. So this is also not the measure of temperature. Energy is ability to do work. Temperature? Yes, temperature. It's a measure of degree of hotness or coldness of your body. Work? Work, not work. Work is equals to product of force into displacement. You will not get here. We will study later. Right? What is the answer? Yes, temperature is your answer. Measure of degree of hotness or coldness of your body. Which of the following is a standard temperature scale? Celsius, Fahrenheit, Kelvin, all of them. Think which of the following is a standard temperature scale? Celsius, Fahrenheit, Kelvin, all of the above. Yes, Celsius, Fahrenheit, Kelvin, all are a standard temperature scale. Based on the usage, we will obtain the scale. On a Celsius scale, the difference between the upper and lower fixed point is divided into. So on Celsius scale. So we'll take all the scales. Celsius scale, Fahrenheit scale, Kelvin. So they are asking about the Celsius scale. What is the lower fixed point? 0 degrees centigrade. Upper fixed point 100 degrees centigrade. So difference between upper and lower fixed point, that is 100 minus 0. What is this? That equals to 100. This is called division. So this scale is divided into how many parts? Yes, 100 parts. Then 180 parts. Which scale? Yeah, let's check. 212 minus 32. So what is the 212 minus 30? 220. 11 minus 8, 180. So which scale? 180 parts is Fahrenheit scale. 273 parts, we have any? Check here. 373 minus 273, that equals to 100. So 100 is the answer. So on Celsius scale, the difference between the upper and lower fixed point is 100. In Fahrenheit, it is 180. And in Kelvin scale, it is divided into 100 parts. There will be no 237 and no 212 parts. What is the process of change of state from gas to liquid called? Let's see here. Here, this is called water cycle. This diagram represents the water cycle, right? Now, so more in your home, you'll have a liquid, right? That liquid at any temperature, it will get evaporated. What is the meaning of evaporator? The liquid state is converted to gaseous state. Again, the gas converts into liquid will be converted into gas. Now gas again converted into solids, that we call it as deposition. The gas converted to liquid solid we call deposition. Snowfall, that is an example, and the solid converted to liquid we call it as melting, right? See here. So solid, liquid, gas. The solid converted to liquid, we call it as melting. Liquid converted to gas, what is that? Yeah, vaporization. Is this vaporization? Now, we will see the reverse. Gas converted to liquid. What is the gas converted to liquid? Deposition. Gas converted to liquid, we call it as deposition. Gas converted to liquid, it is condensation. Liquid converted to gas, it's called freezing. And gas directly converted to solid, solid convert directly to the gas is, if solid converts directly to gas, that is sublimation. If gas converted directly to solid, deposition. Example for sublimation, it's your camphor. What is a camphor? Karpura. Camphor. Naphthalene balls. Naphthalene balls are the examples where they directly convert from solid to gas. And deposition examples are yes, no, right? So now, what is the process of change of state of gas to liquid? Gas to liquid, gas to liquid. What is this? Condensation. What is the answer? Condensation. Evaporation. Evaporation is liquid to gas. Melting, solid to gas. Boiling, liquid to gas. So what is the answer? Condensation, gas to liquid. Heat transfer by physical contact is known as heat transfer by physical contact. What is a physical contact? Direct contact. So see this figure. What the type of mode of transfer of heat here? Convection. Yes. Next. Convection of heat takes place in. So see the solids, liquids and gases, liquids and solids and liquids, solids and gases. See here the figure. So if the steam comes up, right, this is mode is called convection. Whatever the heat you felt around the vessel, we call radiation. If you touch the metal, if you can get the heat, that is called convection. So the heat transferred in the solids are called convection. Convection that may happen in liquids as well as gases. Conduction happens only in liquids. No, no. It may happen in solids, liquids, and gases. But convection does not occur in solids. So, what is the answer? Liquids and gases. A polished silver surface is a. Yes, polished silver surface is a. Think what is the answer? Hmm. Good absorber, poor reflector. No, silver surface is not a good absorber. So good absorber, cancel it. Now, poor absorber, poor absorber. Now, good reflector, poor reflector. No. What's the answer? Poor absorber and good reflector of heat. A substance that allows heat to pass through it is called. What's the answer? Think. Yes, you got the answer? Yes, what's that? Conductor. A substance that allows heat to pass through it is called a conductor. Insulator, which will not allow, which a substance which will not allow heat to pass through it is called insulator. Semiconductor, yes, it allows the heat but in a slow manner. It's not a good conductor. It allows and it will resist. A coin is dipped in the molten wax in a glass tube. If we heat the upper part of the glass tube, the wax around the coil will not melt because see that this is a glass tube and so whatever this is not water. So instead of water you take it as only air. It's an air, right? Glass tube, and in the wax you are inserting a coin in between the wax. Now you are heating the glass tube at the top. Now this coin, whatever the wax around this coin is not melting up. What may be the reason? Yes. Wax has very high melting point. No, if wax is having heavy melting point, so our candle will not melt fast. So option A is wrong. Glass is a good conductor of heat. No, it's a bad conductor of heat. Air and glass are bad conductors of heat. Yes, your option is C. If you are heating the glass tube at the top end, it's a bad conductor of heat. It will not allow the heat to pass through it. So even air will not allow, even glass will not allow. So wax will not melt. If wax is not melting, how that whatever the wax around the coin will melt? So what is the answer? Air and glass are bad conductors of heat. When you heat a bowl of water, what phenomena did you observe? So see the bowl, the water is boiling up. What is the phenomena you are? Yeah, boiling. Here the context we are speaking about that is when you heat a bowl of water, what is the phenomena you observe here? So here water, what is the phenomena you are observing? Yes, water is boiling. Obviously, the bowl of water will boil. Now, what is that? Yeah, convection. Yes, all the phenomena will happen. Conduction happen, convection happen, radiation happen. But we are speaking about the bowl of water. That is water. If the context is boiling, then it is convection. If they are asking about the bowl, then it is conduction. Okay. Answer is convection. Birds glide effortlessly in the air with the help of option A convection currents of air, B radiation of heat, C conduction of heat, D none of the above. Right? So radiation of heat, no. Conduction of heat, no. Now check the convection currents of air. See this figure. Yes, the gravity. So the weight of the due to the weight, so bird will have weight and the gravity will pull down it. So the gravity will acting down and whatever the air, so it will push back that we call drag, that is friction due to air. Now then instead of weight pulling down, drag pulling back, how the board is lifted up and it is moving front. Yes, how the lift forces work. See, while lifting the high pressure and you will have a low pressure. This movement we call it as convection currents of air. Okay, so what is the option? Convection currents of air. When the board is moving, lifting, yes, high pressure air will lift it and the low pressure air will move down. Due to of this, the board can glide effortlessly in the air with the help of convection currents of air. The phenomena involved in sea breeze and land breeze is, so this is sea breeze and this is land breeze. The sea breeze happens in daytime and land breeze happens in nighttime. In daytime, so whatever the warm air in the land will raise up and the cold air from the sea, it will flow into the land. This is called sea breeze. In night time, whatever the air above the land will cool down fast when compared to the air above the sea. So obviously the hot air will move up and the cold air from the land it will move. So this is called land breeze. Now the phenomena involved in sea breeze and land breeze is what? Convection, conduction, radiation, diffusion. Diffusion. So what is a diffusion means? Diffusion is not answer. Moving of high concentration, moving of particles from high concentration to low concentration, we call it as diffusion. So this is not the answer. So best example is your agarbatti, dupam. Doop stick, have you seen the doop sticks? So the doop sticks we call, so the smoke slowly it will merge into the air, right? That we call diffusion. So this is not answer. Radiation, no. Conduction, no. What's the answer? Convection. Moving of air molecules, right? Next. Thank you. This is your level 1. In the next class, we will discuss the level 2 and level 3 problems. Thank you. Bye bye.